Our next presentation will be by Rick Miller from the Kansas DOT. Mr. Miller earned a bachelor in civil engineering from the University of Kansas in 1988. His duties are to oversee and run the optimization-based pavement management system and oversee, build, and run the lab information management system. What do you do on your spare time? The pavement management is used for decision support to help maintain Kansas highways through preservation, maintenance, rehabilitation, and reconstruction. The LIMS is the collection system and repository for data related to materials testing and construction, where it is analyzed for potential changes to construction and materials, practices, and specifications. Mr. Miller is employed by the Kansas Department of Transportation as the pavement management engineer. Please welcome Rick.
So what I do with my spare time is I go to conferences, and often they make me speak, so we'll head off on that direction. Tracy and Chad's presentation was a great tee-up for a lot of what I'm going to say. We do very similar things. We have the same types of equipment. We both are owner-operators, which is a little bit unusual. But we do a lot of the same kinds of things, and their experiences and what I'm going to talk about are pretty well related here, and we didn't coordinate this, but they set me up quite a little bit for some of the things that I want to say. Conceptually, this presentation, I mean, from the title, probably you can gather whatever you think it's about, and that's probably not it. What I want to convey in this thing is that over time, pavement preservation tools have changed, right? Everybody kind of agree to that those have grown over time. Well, the same is true on the data side, that what we've done over time is we've now have the ability to collect a lot more data. What Chad and Tracy described kind of explains that it isn't as simple as just now we got a new truck. You know, there's a lot more to it than that. So what I'm going to point out is that those transitions from one to the next and on the data side aren't particularly easy, and they did a good job of pointing out that they're actually hard. And so what I'm going to point out is we need to be looking at those things, and even though they talked about 176 or 178 or whatever it is variables, I think they even made the point in there that they don't have all of them they need yet. Okay, so we're still not there. Okay, so all of that's just the setup. The early years on both the working on pavement side and the data collection side were very similar. I think Tracy said they only collected data on the worst of their pavements to begin with. So they already kind of knew which ones were the worst ones, but yet they still went out and collected the data on it because some were worser than others, right? So they were trying to find what those were. So in those days, you know, you got some pavement condition measurements, and you also had the here's what we're going to do, which ones we're going to replace kinds of things. It was pretty simple way to go, right? Everybody was pretty happy. It was pretty easy. 95%, probably 102% of the public could tell you which roads you should be working on. So, you know, you maybe didn't even need to collect the data. They already all knew, or at least they'd tell you. So even though it was very easy in those days to collect data, we realized we needed to do more and better. And so some of the things that started happening is we started coming up with panel rating teams, and those were described in the last session, and those things tended to be groups of people or a person sitting in a vehicle and driving down the roadway and assessing it for how do I feel, you know, is it comfortable riding? They may be looking out the window and assessing things like rutting and faulting and cracking, okay? But they were all kind of visual assessment sorts of things. And typically they tended to be fairly small samples, okay? Because, you know, they've got to look at those things over a short distance in order to come up with something they can actually record and report, okay? Nice thing was they were easy to summarize. It was fairly easy to use that data because somebody had assessed it and kind of already put it probably into the bins that you cared about, okay? So it was pretty easy to use, okay? But other folks were looking at that and saying, hey, we probably need to learn more from this data. Some of them were really smart and jumped to the conclusion right away that said, we're not going to be able to build our way out, which I think most of us have finally come to that conclusion, or at some point came to that conclusion. Started to see the mix of fixes strategies and started thinking about how do we apply those and what kind of information do we need to start using all of those tools in the preservation toolbox. And really to start making those decisions, we needed better data, okay? So we started moving from some of these panel things to other ways of getting that data. And there were some steps in here in the interim. You know, there were maze meters and bump finders and all kinds of tools that started kind of moving in the direction of getting better data. But I thought the big step really was when profilers came on. Okay, and what the profiler allowed us to do is, number one, we could collect it near highway speeds. We were collecting a continuous, at least longitudinal profile, if nothing else, so that you're getting nearly 100% sample. They were objective and repeatable. Okay, those are always good things to have when you're collecting data, because that way, at least if you go back and you do it again, you can say, yeah, we're fairly confident that what we're getting is reasonable stuff because we can do it again and again and again. So whether it's right or wrong, at least it's, you know, giving you fairly decent repeatable things that you can say, this is how we're measuring it, what we'll get each time we do that. And the other thing that the profilers did is it moved us from kind of a, you know, a small set of variables to others that were actually being measured. We could take that same profile, we could use it to compute the International Roughness Index, we could use it to compute rutting, we could use it, well, if you had at least 3 of them, you could use it to compute rutting. You could also use it for computing your faulting. So for any of you who had to ever drive down the road and try and estimate rutting, you know, it's not easy. The sun conditions can definitely affect that. Faulting is even worse, because after about the 3rd time the coffee spilled on you, you know, it's bad. It's really bad kinds of things at that point. So, you know, those things become kind of assessments that, you know, now that we can measure them and actually turn them into numbers, they become a much better way of communicating what that information is, which then leads to much better choices, or can lead to much better choices in what do we do about it. Okay? But sort of like Tracy and Chad described, we all are kind of creatures that say, hey, we had these numbers before and we were making decisions based on them, so we better make sure whatever these new numbers are that we can kind of defend that we are going to make decisions based on those as well. So on the slide it says we calibrated these things back. I would argue that more likely we just kind of compared them back. But when we got our IRI values, we started comparing those back to what our raters had said those pavements were before. And it was all just kind of a, let's get comfortable, let's make sure we understand this new data. Not that we necessarily really understood the old data, but at least we were comfortable enough to use it once before, so we continued to say, well, let's make sure these new things are giving us something in the same area. And that was kind of nice. It actually worked for the IRI, the automated faulting and automated rutting. All were giving us comparable results to what we were doing before. And we too would go back and look at the old data and say, well, we think the old data was wrong, or we think the new data is wrong, but at least we could do some comparisons in those places where they were different and deal with the fact that you aren't necessarily getting the same answers. Okay? Cracking was a little different matter at this point. We were still doing that by visual ratings. Okay? And in our case, we were doing 300-foot sections per mile. Okay? So if you think about that from the pulling off the road 3 times per mile for an entire state, and especially in a state where we had a bunch of roads that had little or no shoulders on them, or very soft shoulders on them, it was kind of a dangerous thing to be doing, and it was a little bit scary that we were doing that constantly, and we were very fortunate we didn't have severe problems with accidents and stuff, although we did have to pull our vehicles out of the ditch quite often. So, you know, there were other kinds of complications with that as well that we were trying to get away from at some point. But the good part of the story then is we were pretty fat and happy. We were collecting data. That data was being used. It was being used to make good decisions. We thought about what they were doing in terms of choices for where they were doing different types of actions on the pavements. We had a little chart that was showing that things were all getting better. Everybody was pretty pleased with that. So you know, we were moving along nicely. But because of those safety issues, because of something called MAP 21 on the horizon, we realized that we probably did not have all of the data that we needed, and we probably were not collecting it in the best of ways. And so we started looking at other options. And in our timeline, this would have been around 2010 was when we were looking at this. I at one point talked about or considered doing timelines for all of these things, but they're very different in different places, different states, and even the order that they occurred is different in different places, especially when you start playing the game of this change in data collection led to this change in pavement preservation actions, or vice versa, because in some places the need to try and determine where to do certain types of preservation was pushing us to look at the data options and see what we could do to improve that data. Okay. So around 2010, we got serious about looking for a different way to collect the data. Our equipment that we had was getting old and tired. Our people that we had were retiring. So between those two things, we were kind of starting to realize we had to make some pretty big shifts in what we were doing. And where we ended up going is we said, well, we want something with 100% sample, and no longer do we just want that to be a longitudinal profile 100% sample, but we really wanted the entire roadway surface. So we started looking at 3D systems for that. And you'll notice there I listed as roughnesses, ruttings, faultings, and crackings. Okay? Because one of the things that this did is before we had 3 profile paths, right? So we could only do a limited amount of data analysis with those 3. Now that we have essentially clear across the roadway a profile, and we have that both longitudinally and transverse now, we could do a lot more in terms of getting data. So the 176 can turn into a couple million if we're not careful. So we ought to be thinking about which of those couple million alternatives are actually the ones that we would care about and should be caring about. Okay, so we had data like a fire hose here. It was coming out from every place. Lots of new information that we needed to determine how are we going to use it. Some of these systems we could more or less just say, well, it's just like the old system, or we're going to get very, very comparable answers. Others of them would be quite different. And some of them would be easy to compare back, and others wouldn't be so easy to compare back. And I'll make the emphasis again, what we tried to do were comparisons, not calibrations, okay? Because really what we wanted to do is we said we're collecting data in a different way. We want to make sure we're using that data in the best way we can, not just getting a different way to get to the same old results, okay? Not that we don't still do some of that, because some of it we still haven't come up with all of the transitions to get it from what we used to do to being able to use and ingest the new data. So I'll just show a few pictures here. This is just a forward-looking. It's a real road in Kansas. It just happened to be one that we picked. I think I grabbed 5 roads to try and come up with one that would work as an example, and this was actually presented back in 2013. And the intent at the time was just to show that these things do sort of compare. You're looking there, and probably you can't see it very well, but that's 4 images across the screen there. And from the right, the farthest right one, is an overlaid image. So the purple lines are the AASHTO bands for the zones. The green that you kind of see at the top is where the automated system identified a crack in that road. And then the rest of it is just an intensity image, just like a photograph. The one right beside it is the same thing without the overlays blocking it, so you can actually see what's there if you're up close. The other 2 are what was really different to us. Those are the range images, or the relative range images. And essentially what they do is they're measuring the height at each point on that pavement. And by using that relative height, anything that was deeper becomes black, and anything that's higher becomes white. So grays are in between. So it starts to jump out at you where you have cracks. So hopefully on the projection you can see that there's actually the crack there that it identified, okay, in the automated system. All right, so the first comparison that we did was with the IRI values from our old data collection system to our new data collection system. And frankly, these systems weren't much different. We were not using the 3D profile data for this IRI value. We were actually using a profiling system connected to that same vehicle for these. So you would expect them to be very much the same, and largely they are. The vendor of the equipment, Manley, pointed out that they made all of our roads a little bit smoother in this, and they didn't charge us any extra to do that. We pointed out that we didn't make them pay a penalty for screwing up all of our historic data at that point. So, you know, however you want to look at these end up telling us that the values that we were getting out of the new system for IRI were very similar to the values that we got before. So we moved on to other distresses, or to distresses then, and we started looking at transverse cracks. And across the bottom, each one of those bars is representing 1 mile, which is the nominal length of our pavement management sections. And the blue bars on there are representing what our manual distress raters had looked out the windshield the year before and assessed in terms of the number of transverse cracks. The red bars are what the system, the automated system in 2013 came up with for those cracks. So we looked at that one and we were extremely happy, going, great. We basically paid a lot of money to get a new system that gives us very much the same answers that we were comfortable with before. Okay, so that's a good thing because that made us comfortable, right? So then we moved on to looking at a little different distress. This one would be sealed cracks, okay? And in this case, again, you know, those first couple of miles looked pretty good. The rest of it, you know, we started having some questions. And what this led to was questions that went all the way back to the manufacturer and asked them some things about how they come up with their sealed cracks. And they were great discussions. We learned a lot about what they were doing. They learned a lot about what we were doing. The fact that we didn't band our crack sealing stuff was kind of new to them. And so it was kind of a difference in terms of the way that they were, what they were looking for. So they revised their system some, we revised kind of what we were looking for out of it, and again kind of merged those together to come up with something that we were comfortable with. So another comparison, this happens to be fatigue cracking. You can see there that there's a huge difference between these. Now remember, our manual distress was done on a sample basis, 300-foot sections per mile. Okay? The automated system was measuring the entire length. Okay? So on going back and reviewing these, which we could, because we could go back and look at the individual images and go back and if we could determine where they were when they did the manual distress rating, we thought we could come up with an answer that would match that 100 feet and do those comparisons. And that kind of a comparison probably would have given us a better type of comparison between the old and the new. But we weren't going to do that on every piece of roadway that was out there. So we had to figure out how are we going to use this new data in order to do that. Because now we are getting a 100% sample. And just like rutting, where, you know, if you were taking a short length sample, you may get much higher values than if you're averaging that out over an entire mile or something. Okay? So the same thing starts to happen with your cracking data. All right, so we learned a bunch of lessons in 2013 in doing those comparisons. The profiler we were pretty happy with, but what it really made us start thinking about was opportunities to use that data in other ways, to actually not just try and link that back to what we did before, but actually consider where are we going, what kinds of opportunities do we have to use this data in a different way. Okay, so in the lessons that we've learned since then, and the opportunities that it gave us, is we started thinking a lot more about how to use those surface elevations, the fact that you're now getting that clear across the roadway, the fact that you're no longer using somebody's eyeballs to assess whether or not what the angle of that crack is and those kinds of things, that you can actually get those measurements out. And we started looking at using all of that data in different ways. The real question there is the bottom one, and that's what I would challenge most of you to do, is if you are changing these systems, it's great to do all of these comparisons. I think what Kentucky's doing, they have to do that really, because they've got lots of history and systems that are dependent upon getting variables very much like what they used before. But I would also challenge them to look at, you know, are there other ways that that data could be used? Are they missing things that would lead to other types of preservation treatments or other activities that could come out of that? And I think they're doing a lot of that. I'm just, you know, that's part of the process to get there. I would argue we're probably behind them in terms of doing that, because we did more or less the same thing and said we're going to have to convert these back to our old systems at least to start with, so we can continue running our optimization system and making our choices from there. So we've got to decide how we're going to use all of this data, and some of the things that I might challenge folks in this room to do is go back and look at that and maybe say something like, since you can now compute IRI not just, you know, in the wheel paths or wherever you had a profiler type sensor, you now have that clear across your roadway, that maybe something about the variability in IRI across the lane might tell us a lot more about the pavements. Was also noticing things like there are a lot of applications of preservation treatments where they were intentionally not doing the joint between the lanes, where they were intentionally not doing whatever the treatment was over those. And maybe that starts to tell us something about when can we get away with that and when can we not do that, because you have that data available to you. You still have the cracking data clear out to the joint. So we might be able to find that there are new and better statistics than the ones that we have been using. We, for many years in Kansas, used a 3-point rut system, and there are people around that just, every time we set it, they would just go ballistic that, you know, it's not a very good measurement of rutting. And I would agree with them that it's not a very good measurement of rutting, but it worked perfectly well for what we needed at that time. If you were comparing our rutting to anybody else's rutting, it probably was not a reasonable thing to do because it's a different measurement, a 3-point rut and a 5-point rut. In doing some of the work that we've done with AASHTO and trying to come up with new definitions and new ways of computing these things, we're kind of looking at things that say maybe rutting isn't even the thing that we should be measuring with that. Maybe it's a pavement deformation type statistic or something like that. Maybe you have to include with the rutting information cross-slope data or something else that tells you more about what's the impact of the road not being the shape that you want it to be. Okay? So that's kind of the challenge, is figure out, we've got the data to do it, we got to figure out what to do and then what it tells us and how to react. Okay? And then even the things like faulting, which it used to be that you would jump out of the vehicle and run over and put your little Georgia fault meter on there and come up with a measurement. Of course, that's hard to do at 60 miles an hour. We don't have many folks who can run that fast. So instead of doing that, to be able to literally drive down the road at 60 miles an hour and come up with measurements of faulting, and not only can you do that at one spot, you know, a foot off of the edge line or in the wheel path or wherever you want now, essentially, is that system can look to see, is the faulting different as you go across the slab? Maybe it is, maybe it isn't. If it is, maybe that tells you that you have a different problem than if it is the same all the way across the slab. So maybe we can learn some more things from that. So the message out of all of that is that we do have a lot of data available to us with these new systems. In some respects, the federal rules are forcing us all to go to systems like this. So like it or not, whether you like your old manual distress rating, whether you like the current automated systems that you have, you're going to have to do things the Fed way for some of these things anyway in the future. And so you better be kind of marching in that direction of learning how to use the data that's available to you or that you're going to have to collect anyway. You might as well get what you need while you're out there. And that's something we've been very proud of in Kansas, that we've collected data from 1983 to now. We continue to use that. We continue to look at how to use that. But most importantly, it ends up affecting our pavements, and they end up being in reasonably good shape throughout the state, which makes the people that pay us very happy. Okay? So to use this data is very important, and to get to that point is very important. So with that, any questions? All right, thank you.